Okay. All right, everyone. Hello. Welcome to week two of this class. Uh, like Frederick said in the chat, if you haven't already, please fill out the attendance form for this week. It's posted in course material in the Discord. So if you haven't done so already, please do that. We did meet our goal of 80% for last week. So um, if we can continue that again, um, we I will try to bring food on the last week. So yeah, please fill out your attendance forms. I would like to eat food with you all. So yeah. Anyways, getting back into the course. Today we're going to be doing some more stuff that and building off of what we learned last week. I dabbled a little bit with geometric constraints, but we're really going to hone in to them today. We consider this to be a little bit more intermediate compared to what we were doing yesterday. But geometric constraints will really help you hone in your designs, especially with your sketches. Um, so again, like before, a constraint is just a tool that we use to define our sketch, right? So last week I was talking about fully defining our sketches, making all the lines or arcs black. So that's, how we define it, right? Um, and we can use constraints to relate multiple things in a sketch to each other, right? We can make two lines equal to each other, which we'll be doing a little bit today. And we have many options. Um, the other thing is it allows us to kind of hone in our design and kind of simplify the modification process, right? So if we use geometric constraints, we can leave a couple dimensional constraints uh, and then make it easier to change in the future. So without further ado, let's introduce some of them. So if you take in geometry, you might be familiar with a lot of these terms. So stuff like concentric and parallel and perpendicular might be pretty familiar. But there's a couple others that might be new to you. The main one being the coincident constraint. So coincident, like the description says, you basically just take one thing and you want it to kind of merge with the other thing. So, you could have a point and a line, and you're like, oh, I want this point to be on this line, or I don't know, this line to be um, like touching this circle, right? So it's going to be coincident to that circle. So that constraint is pretty useful. Um, Collinear is just like having two lines being the same or on the same axis. So if you have, two lines that you want to kind of merge into one line, you can use that constraint. Again, concentric. I'll have two circles or ellipses centered on the same point. The midpoint, like it's in the name, it's just gonna make something in the center of something else. So that would be like, if you want a point to be in the middle of another line, you can use the midpoint constraint, or you could have like two lines being midpoint to each other, something like that. Um, the fix unfix constraint is useful in some very rare scenarios, but I encourage you to kind of avoid this at all costs, um, or not at all costs, but in most scenarios, um, you can use another geometric constraint to fix something in place, right? So, um, you know, you can make two lines perpendicular or use a couple other constraints to fully constrain your design instead of using the fixed constraint. Um, because basically what it does is you can kind of drag whatever the thing you want to constrain into an arbitrary spot and then fix it in place. So in my opinion, it's kind of less precise if you do it that way. So kind of avoiding that is preferred. Um, there's some like very specific scenarios where using the fixed constraint might be a good idea. But that would be more advanced, like, maybe using an equation driven curve or something. So you can like write an equation um, for Fusion or your CAD program to follow, and then it'll draw like an arc or a line or something like that based on that equation, and then you can fix that. But most of the time, uh, you won't be using it. Parallel and perpendicular should be pretty self-explanatory. Two lines being parallel is just kind of in line with each other. Perpendicular, 90 degrees from each other. Uh, the other ones that might be useful to you might be like the horizontal and vertical constraints. So if you're drawing something and you want to make sure it's going to stay on a certain axis, horizontal and vertical is usually a pretty good place to start. Tangent is also very useful. I think we used it a little bit last week with that game piece, but it's kind of helping you get a very smooth curve or a smooth transition between like lines and arcs, right? So if you want, a line to be tangent to it, you should be using that. Um, Smooth, I don't really use as much, but that's certainly an option. But then equal and symmetry are both pretty solid constraints. Obviously, everyone might have their own preference on which constraints they might prefer. And to fully define your sketches, you can probably use several combinations of a lot of these constraints and still get the same result. So, again, when you're designing things, we're just here to give you tools, and then you can kind of utilize them as you please. So yeah. Um, so we're just gonna jump into it today. So in the Discord, we have this document here for you to download and open. So if you go into the Discord under resources, there's this geometric constraints file. So you can download it and then we'll import it into Fusion momentarily. Um, So here I'm in Fusion. I have my workspace here, but I'm gonna upload this design or this file that we made for you. So to do that, you might want to first start by opening your data panel if it isn't open already. So I'm just gonna go up here in the top left. It's gonna kind of open my drive over here, and then I'm gonna find a good spot for it. So I'm gonna go here and then I'm gonna click upload in this case because we're gonna upload a file and then I'm gonna find it in my file explorer. Uh, so you're gonna find it. It's probably in your downloads folder. You're gonna open it. It's gonna tell you what you're uploading. You confirm the upload in the bottom right. And then if we wait a little bit, it should upload and allow us to open it. Okay, cool. Upload complete. You can open it. So I'm just going to double click it. And this will kind of become available to us. So I'm going to hide the data panel just so you can see a little bit better. If I orbit, you can see there's kind of like a plane here with a photo and some text on it. And then there's some, circles and lines that we're going to uh, use geometric constraints to practice. So to edit these, we're going to have to enter in the sketch. So if you remember from last week, we have the timeline on the bottom, and we can use the timeline to kind of go back and edit things, right? So down here, you can see here there's a photo, which is, like this canvas here with all these words. And then there's a plane, and then there's a sketch here, right? And if we hover over it, it'll tell you exactly what these are. So here on the last one, there's a sketch. So to edit it, I'm going to right click and then click Edit Sketch. And your view should fly into the plane that the sketch was sketched on. So you can see here, now that I've opened the sketch, we have all the sketch tools that were available to us just like last week. Last week we're kind of focusing more on the left side with like the lines, rectangles, and circles and stuff. But now we're going to focus our attention on these more red icons in the middle, right? So there's a couple of them up here. If you want all of them, you can click on this drop down here and it gives you a bunch more. Um, so we're just going to kind of go through and do some of these. I'll do a couple of them and then I'll let you all go free and try to do it on your own. But then, of course, I'll be here if you need help doing any of them. So I'm just going to start in the top left. So over here, the text up on the top says make it perpendicular. So you can see right now, these lines are free to move. For all of these, a lot of them will be blue just because they're kind of floating in arbitrary space. But we're just, doing that to practice. But again, if you're making your own sketch, I highly recommend, you start at the origin and you fully constrain everything. So all the lines become black and fully defined. But again, we're just practicing these, so they're just kind of going to be floating around. So to make these perpendicular, we're going to want to use this perpendicular tool up here. So there's a couple ways you could go about doing it. You can click the tool and then click the two things that you want to be perpendicular. But for me personally, I just like holding Shift and then clicking both lines. You can see they kind of get highlighted because I'm selecting them both. And then I click the constraint that I want to apply. So in this case, I want them to be perpendicular. So when I click it, bam, perpendicular to each other forever, or unless we delete the constraint. So yeah, that's kind of what we're looking for. But there's a bunch of other ones. Um, so did perpendicular. Now we can do parallel right next to it. So to make these three lines parallel to each other, I'm just going to hold Shift, select two lines, make them parallel, and then I'm going to make these two parallel to each other as well. And you'll notice sometimes when you choose one of the constraint tools, it'll lock you into it just because it'll be highlighted blue. So if you ever want to exit, you can easily just press escape or something. Uh, and you can kind of move things around or do other things like select other objects or lines to constrain in other ways. Okay, so this third one is a little bit more tricky compared to the other two. So this will use a combination of dimensional and geometric constraints, right? So we have three circles here. They're labeled 1, 2, and 3. So the instruction here says to dimension circle number 3 to a diameter of 2 inches. So the diameter symbol is the circle with a diagonal line through it. And then you want to fix circles 1 and 2, and then make circle 3 tangent to both of them. So to do that, I'm going to start by dimensioning circle number 3. So instead of going up here, we're going to be using the dimensional constraint or the sketch dimension tool here. Oops, I selected that line already. I just pressed escape a couple times. Gonna open up the tool again. I'm gonna click circle number 3. You can see it's not quite 2 inches in diameter, so I'm gonna set it to 2. And then it's asking me to fix circles 1 and 2. So I'm going to press escape to get out of the sketch dimension tool. And then I'm going to fix these two circles. again, I usually don't use this tool, but you know, it's nice to know how to use it. So I'm going to fix it. I click the lock, the tool is selected. I'm going to fix this and this. You can see it kind of turns into this like yellowish green color. So that's just to signify that it's been fixed instead of, constrained in like the quote unquote conventional way. Um, so again, before we constrained them, you know, these were just kind of floating in arbitrary space. Um, but now that we fixed them, they can't move. Okay. All right, I'll get to that question in one moment. Okay, so for the last one, or for the last part of this uh, exercise, it says make circle number three tangent to one and two. So the tangent tool is right here. Again, you can do the shift click thing, or you can just click the tool. I'm going to click one circle, the other one. You can kind of see it flies into place. And then I'm going to click these two. And because these two circles are fixed, it also fully defines this circle number three. Yeah. Okay, so I had a question. It says on the perpendicular constraint, how do we fix the second line and make the first line to be perpendicular in respect to the second line as opposed to what you did? So, okay. So if you're wondering, like how I could have made it so the first line like stayed like in one place and then it went perpendicular to the other, um, you kind of just uh, apply the constraint and Fusion will kind of assume one thing and just make it work, right? So Fusion will kind of do it in, I guess, the easiest way it thinks it knows how to do it. And it may not be exactly what you wanted, right? So to make it the way you want it, you usually apply more than one constraint. So when there's two like lines that are just kind of in arbitrary space, because none of it is defined, Fusion will just kind of choose the path of least resistance, and then just constrain it. And again, it may not be in the direction you want it to do. So sometimes there's things you can do to kind of move the line in like the general direction you want it to go, just to kind of encourage uh, Fusion to constrain it a certain way. Um, but again, if you really want it to be a certain direction, it's a good idea to apply more than one constraint. Does that make sense? Okay, cool. Okay, someone asked, how do I get the circle one and two to be green? Uh, oops. So they're green because I have made them fixed in place. So I can unfix them real quick. So you see there's this locked icon for the fix and unfix constraint. So to make them fixed, I just choose the tool and then click what I want to be fixed. In this case, is those two circles. But yeah, there's a couple other of them left, or a couple others left. I'll let you all run free to do them. If you need help, just let me know. But maybe we can hang around for maybe like 10 minutes or so. Um, yeah, good luck. Again, I'm here if you need it. So feel free to ask. Are we allowed to make new lines? You shouldn't have to be making new lines unless you accidentally deleted one that already existed. So yeah, for this assignment, you shouldn't be making new lines. How do you specify horizontal versus vertical? Okay, that's a good question. So, like I was saying a little bit before, um, because like the horizontal and vertical constraint is kind of combined into one tool, you kind of have to like massage your sketch to kind of imply which way you want it to go. So like if a line was closer to horizontal, Fusion will assume that you want it to be horizontal and then it'll make it horizontal. And then the inverse would be true as well. So if your line was closer to vertical, it will try to make it easy for itself and just make it vertical. So if it's not going the way you want it to go, then you could try to undo that constraint and then kind of either move your line or add other constraints to imply that it needs to be one or the other. Okay, for the last one, it says make the circles horizontal. Okay, I did kind of forget about this one. If you want, yes, you can add a line to this one and then make them coincident to each other. I forgot that you needed to draw a line for that. Um, it's also technically true if you made all of them concentric to each other. So um, feel free to do that as well. I'm not going to grade too hard on these, so don't worry too much. That works too. Yeah, the collinear constraint works.
You got this. Hey, congratulations. I just have extreme joy when I unlock the door. Because you get to see me. Because I get to see exactly. I'm doing a beginner CAD course right now. This is so fun. CAD is really fun. I have 7 years of CAD experience and I'm just smurfing in this class. Is it required? No. I was like, oh,
Yeah. Okay. How is everyone looking for this? Everyone looking okay? If not, it's okay because uh you can go back and do this later. But now might be a good time to transition to the next assignment. Is anything on this assignment particularly confusing that you'd want me to address right now? If not, then uh, we can move on. Okay. Could I do number four? If by number four, you're talking about the top left one or the top right one, is that the one that you're looking for? Five. Uh, is it this one with the circle and the two lines, kind of like a V? Okay, cool. So here it says fix point C, and then make endpoints A and B coincident with point C. Um, so the A and B are just kind of floating out here. But I'm just going to assume that A is here and then B is here. So here we're going to use the fixed constraint again. So we're going to use this key or this lock, click the center here. It's going to fix this point. You can see that the center here or the center point of the circle is kind of the greenish yellow, but the outside is still blue. So that means you can still constrain it. Um, but yeah, so if I wanted to, I could still, change the size. So here, the other part of it, it says make endpoints A and B coincident with point C. So I'm going to use the coincident constraint up here. And again, I'm just saying A is here and then B is there. So there and there, and there, and there. Okay, I messed up the first one, so let's fix that. So I'm going to make sure I select the center and not the outside. There we go. And there. That should be good. Okay, someone asked if there's a good way to undo constraints. Um, Honestly, that's one of the things that frustrates me sometimes is that it's kind of hard to see the constraints. So sometimes it's kind of hard to fix. Um, so sometimes if you can find them sometimes if you hover in the right place. But sometimes or most of the time I resort to using Command Z or Control Z to undo. But if you can find it, so in this case, let's say I didn't want this line to be parallel to this one. If I hover in the right spot, you can see these little icons will pop up. So in this case, these two lines just look very similar to the parallel constraint here. So if I can find it, I can click on that constraint and then I can delete it. And you'll see now, if I delete it, it's unconstrained. And then I can put it back by reapplying this constraint. So yeah, it's kind of annoying because they kind of hide from you. But if you can find them, you can delete them. But yeah. All right. So with that, I think it's a good time to move on. So I'm just gonna finish this sketch and um, we can start on the next assignment. Okay. So assignment 5 is we're going to be creating this gear here. Again, there's some dimensions here on the screen or on the PowerPoint. What you do doesn't have to be exactly the same as this. So if you wanted to make the diameter smaller or larger or something, it doesn't matter. The most important thing is just learning how to use the tools, right? So the main ones we're going to use here is the circular pattern tool, the hole wizard, and that includes the thread tool. So everything else will be stuff that we've previously learned, including geometric constraints. So yeah, let's just get started. I'm going to create a new design here in the top right. Be presented with a nice blank canvas. And just like in many of our other assignments, I'm going to start with a sketch. So up here, top left, I'm going to select a plane. And then we're going to start drawing. So to create this, you can kind of see what we're going to be going for here. But the cool thing is we're going to be using some tools to ensure that we don't have to draw each individual tooth. So we're going to start with a circle. We're going to draw the tooth profile, and then we're going to copy it. So starting with the circle, going from the origin, pulling it out, and then I'll constrain these in a little bit. I'm going to add a vertical line here, and then I'm going to go across and create half a tooth profile. So basically what I'm going to do is I'm going to create a construction line. So a construction line is kind of a line that us as designers can utilize when creating our sketches, but they'll largely be ignored when we go to make operations like extrudes and revolves and stuff like that. So it's pretty useful. I'm gonna take this construction lines um, by enabling it over here. You can also change a line to a construction line later. So I'll just do that right now so you know how it works. So starting from the origin, make a line here. I'm gonna just kind of go out in this direction just to show how to use some more constraints. I'm also just gonna finish this tooth profile. So I'm gonna go across and then back down to the circle. So you can see right now everything looks a little bit weird, but we can fix that with our constraints, right? So we could have drawn it straight up, but I'm just showing you that you can use these constraints to make things the way you want. So for starters, I'm going to make this line vertical. So I'm going to select it, make it vertical. Again, uh, I'll show you like how like the arbitrary thing works. So you can see now if I put this line here, um, if I choose the horizontal or vertical constraint, it'll make it horizontal because it's more closer to a horizontal line to a vertical line. So that's just kind of how Fusion and lots of other CAD programs think. So if you want it to be a certain way, you might have to massage it in a certain direction. So again, make this vertical real quick. Oops. Oh, come on. There it goes. Okay. So now this is vertical and make this horizontal. So that's nice. And then we can start to add some more constraints. In this case, we're going to be adding some more dimensional constraints. Before we do that, I'm going to make this a construction line. So I'm going to click this vertical line. I'm going to make it construction by clicking this. The other way you can do it is by right clicking and do normal slash construction or press X. You'll see whenever I change it, this highlighted profile of the tooth becomes white. So that means that it's not a closed body anymore or like a closed sketch because Fusion won't recognize your construction line as like a solid line. So if I wanted to extrude this tooth, because it's open on this side, it won't let me when I try to extrude it. So keep that in mind. Um, Depending on your circumstance, this might be a good or a bad thing. In this case, it's totally fine. So I made that construction, and then I'm just going to start adding dimensions. So I'm going to specify this radius. Why not make it 100? Um, make this, I don't know, 5. Uh, I'll make this smaller, maybe like 50. Oh, I made it 5 instead. Oops, that's fine. Okay. And then I'm gonna add a couple more. Oh, my computer's laggy today. Gonna dimension this, set this angle to 100. All right, cool. So now here you can see we have our half tooth profile. So what I'm gonna do now is I'm gonna copy it and mirror it across this construction line. Oh, how do I do the angle? Okay, I'll do it again real quick. So I use the sketch dimension tool and then I select 2 lines instead of just one and I can change it. So why don't we do, well, maybe not 90. how do I take it off construction? So if you have a line that you may have accidentally made a construction line, for example, let's say you just did this, you can again click the line and click X to change it. You can use this icon right here to turn it on and off, or you can right click it uh, and change it here. So a bunch of ways to do it if you accidentally made a line construction that you didn't want to. Okay. Anyways, so what I'm gonna do now is mirror these two lines across this construction line here. And the reason why I'm doing this is I just have to add these dimensions once, right? And because I mirror these, um, the two lines that I create here will copy everything it sees here. So that kind of reduces um, the number of constraints that I need to apply. Um, and it'll make changing things easier, right? So I'd say like the trick to CAD um, is being kind of like as lazy as possible and let the computer do a lot of the work for you. And because you might be lazy and make the computer constrain a lot of things for you, it'll allow you to um, change things easily later. Okay, if you're talking about the thread tool, you're a little bit ahead, so just hold tight, but um, it's the same as making the whole tapped. Does Fusion have a constraint view button? The sketch looks pretty messy with all the constraints everywhere. Um, Not to my knowledge. They just kind of hang out there. Um, it does in some cases kind of get annoying, but I'm not really sure how you hide or show them. You might be able to Google it. I'm not sure. Um, but yeah. Anyways, I keep getting distracted. I'm gonna mirror this. So over here in the top left, you've been doing like the line, the rectangle and circle. But you can see here, there's this mirror option right next to the dimensional constraint. It's going to ask us to select the objects we want to mirror. So in this case, it's this horizontal and diagonal line. And then it'll ask what line I'm going to mirror it across. So I'm going to click this select button, and then I'm going to click this construction line. And then I'm going to press OK. So you can see now, now that I mirrored it, um, this area is now closed and this zone is now highlighted, right? So that's a good thing because we're going to be extruding this in a moment. So that basically shows that it's a closed body. So that's good. All right. So now that we have this, you can see that if I were to change any of these dimensions, it's gonna change on this other side too. So for example, let's say I wanted this to be thinner. You can see that when I change this side, it'll change with it as well. What if it's not blue? Okay, if it's not blue, that means that there's a point somewhere that's opening up your um, your sketch here. So it could be that maybe this diagonal line isn't fully coincident with the circle here or something else. Could I show where the mirror tool is again? Yes. So I'll just delete these lines real quick. The mirror tool is right next to the dimension, sketch dimension tool. So just select it, select the two lines you want, and then select the mirror axis, in this case, the construction line. And again, so you'll see here, like I was being like quote unquote lazy by only adding these two dimensional constraints. But it's really nice for us later because if you were to change it, well, I guess I added this third one here. If we were to change any of these later, then the rest of the tooth will follow. And we can expand on this by patterning what we have here around the whole circle. So again, we only drew one tooth, but in doing so, it'll allow us to change all of them at the same time. So to do that, similar to the mirror, there's the circular pattern tool. So if I go on the drop down, there's also the mirror option here, but there's also a circular pattern option just below it. So if I click it, I'm going to select the objects. So in my case, I'll select these four lines, and why not? I'll select the construction line too. The center point is the center of which, um, all these uh, lines or arcs are going to be patterned around. In this case, it's the origin right here. Uh, and then I can specify uh, how many I want or the distribution. So because I want them to be spread evenly, I'm just going to set this to full. But if I want it to only be patterned, a certain number of degrees, I can do that as well. But I'm just going to leave it as full. And then I'll start adding teeth. So if I type 10, you can see it previews as more. It probably even go higher. So add how many ever teeth you want. And then when you're satisfied, you just press OK. And now you see we have a bunch of teeth and it's looking a lot more like a gear. Again, because we copied the feature from this original tooth profile, if we change anything, it all changes with it. Can I repeat the mirror part and the whole repeat thing? Yes, I can. Okay. Okay. So back here, I'm going to do it real quick. Select mirror, click the two lines that I want, select the mirror plane by clicking this, then plane, or not the plane, the line, and press OK. And then to circular pattern, I'm going to go under create circular pattern, select the objects, and then the center right here. And then it's already set to full, so I'm just going to specify how many I want. Everyone good? Okay, I'm going to assume everyone is. So now that I'm satisfied with this, I could press finish sketch if I wanted to just extrude it. But what I am going to do before I do that, this is optional, but I'm going to trim away all these little pieces um, that connect the circle to the teeth. So I'm going to do that just so I don't have to select all the bodies when it comes to extruding it in a moment. But depending on your scenario, this may be something you want to do or not want to do. So I'm going to use the trim tool and I'm going to start trimming away. So I'm going to cut these lines here. I'm just going to kind of go all the way around. Oops, I cut the wrong line. So just trimming away. It'll make our extrude just that much easier. All right, cool. So you see, now that I've trimmed it all away, this is all one closed body. It's all highlighted blue in the middle, which is good. All the rest of the arcs and lines are black, so it's all fully constrained. So that looks good to me. So satisfied with it, I'm gonna press finish sketch, and then I'm gonna extrude it. So hit extrude, specify distance, maybe like 5 or something, maybe a little bit less. Okay, so I'm just doing 1 millimeter because my gear is kind of small, but again, you can do whatever dimension you want. I'm gonna press OK, and there we go. We have our basic gear down here. Okay, everyone with me now? Everyone good? Okay. I'm gonna assume everyone is. So the last part on this assignment is adding this hole in the center. And you can see this hole has threads in it, right? So we're going to be using the hole wizard tool. Um, oops. Uh, One of the reasons why we recommend you use the hole wizard, um, as to, you know, just making a straight hole with a sketch and a extruded cut, is that you sometimes lose data, for or when you do like the sketch and the cut, right? So the cool thing about Fusion is that it's kind of like an integrated software where it can do multiple things, right? So right now we're just designing parts, but later you could take these parts that you design in Fusion and then send them into a CAM software inside Fusion to program something like a CNC machine, right? So if we had this part, we have this gear here, and we want to cut this out of a block of metal with a mill, um, we're going to need to program that machine to cut it out, right? And in our case, we want a hole in the center. So we could just make a sketch, draw a circle, and then extruded cut it away. But you do lose data, right? So what I mean by that is in the hole wizard, you'll see in a moment, there's a bunch of different options like hole diameter and like, drill bit taper angle, which is kind of not really important for this scenario. Um, but it will Fusion will treat a hole made from a hole tool and a hole made from a sketch and extruded cut differently uh, when um, when programming it in CAM. So if you think about it, I mean, if you have some machining knowledge, you might know what like a pocket is. So a pocket is basically, like a hole where you typically use something called an end mill to kind of hog out the material, instead of a hole where you just use a drill bit and then drill out the center. So again, if you don't use um, the hole tool, then the CAM might treat uh, the feature differently. Um, and in this case, we want threads. So it's even better to use the hole tool instead of having to model like a thread profile and then, spiraling it down our part. So the hole tool will make things easy if you just want a drilled hole or a tapped hole. So I highly recommend you use that if you plan to machine your part in any way. So I'm going to enter the hole tool here, just clicking on it. And again, there's a bunch of different options here. So um, in our case, I'm just going to select the center, but you can use a sketch, um, to specify different points if you want to. So in our case, I'm just going to make it in the center like that. But now we have a bunch of options, right? Uh, for hole type, you can see there's three different kinds. So, if a simple hole is just, one size, it just cuts at a distance that you specify. A counter bore will kind of add an extra wide part on the face of the hole so you could fit something like a socket head screw. And then a countersink will have kind of a tapered end for something like a countersink bolt or screw. Uh, Underneath is hole tap type. So we're going to be tapping today. So tapping is just another word for adding threads into something. So um, we're just going to use tapped. We want it to be tapped. I'm just going to leave it as full, but you can see there's a bunch of options. Um, you have different drill options, but in this case, because we want it to go all through, I'm going to set the extent instead of distance to be all. So I want it to be drilled all the way through um, using a simple hole, and then it's going to be tapped like that. You can kind of see the beginnings of our feature here, but here we can be a lot more specific, right? So here you can select your size, and even like your thread pitch and stuff like that. So in this case, it's a 2 millimeter hole, so I can pick between these two. Um, I'm just gonna pick that one. But again, you can see here that the whole tool has a lot of data that you could be losing if you're using the extruded cut, right? So remember to keep this in mind when making stuff because you might not be the one machining it. So leaving that extra data for the person who is making it could be very useful to them. So I'm satisfied with this. So I'm just going to press OK. You can see now there are threads in the hole. So this is a complete assignment right here. And if you were following along, you can just take a screenshot of this and you'll get full points. Again, make sure that for assignments going forward that you have a photo of your timeline included in your screenshot. So, you could take a photo, you know, in kind of like this area like that, because I want to see that timeline to kind of make sure you're doing the process correctly, right? Especially if this assignment was just a hole with no threads in it, then you could be developing bad habits by just extruding, cutting, or sketching and then extruding it instead of using the hole tool. I know I like said that like 5 times, but it is something to think about. But yeah, any questions for this assignment? Okay. If there's no further questions, just move on. All right. For the last one, um, we're going to be making a hair dryer. So we're going to be creating some extra planes, uh, and then using the loft tool to connect multiple sketches. So typically when we've been modeling our parts so far, we've been kind of limiting ourselves to the three planes on the origin when we first start. But there are many cases where you might be tempted to create extra planes that you want to build off of, right? So sometimes you might have, you know, two faces and you want to create a feature that's in the center of them. Or, you might want to have another feature that's offset or tangent to something else. So to create that, sometimes you might need to use a plane. So we're going to teach you how to use planes today, and we're going to show you some of the cool things that it can do. All right. So going back to Fusion, I'm going to create a new design. And then instead of creating a sketch like we normally start out with, we're going to build a couple extra planes before we start. So I'm going to unhide this real quick. You can see here, there's the three planes that are kind of connected to the origin at the start. We're going to create a couple more. So to do that, I'm going to go under this construct dropdown, and I'm going to choose offset plane. I'm also going to be using a midpoint or a midplane just to kind of show you how it works. But you can see there's a bunch of options for you to choose from depending on your scenario. So I'm just going to start with a simple offset plane. So I'm going to select this one. I'm going to select this plane right here, which is the top plane. If we look at the view cube, and then I'm going to specify some distance, right? So I don't want the planes to be overlapping, so I'm going to add some distance between the two. Maybe let's just do 10. Again, these numbers are arbitrary, so if you want to use a different one, then you totally can. I'm going to add another offset plane. This time I'm just going to add a larger one, maybe like 50. And for the last one, I'm going to use a midpoint plane just to show you how it works. So I'm going to select two planes. In this case, I'm going to select the one that's pretty far away. And then why not select this bottom one here? You can see it creates a plane that's smack dab in between both of those. Cool. So we've got three extra planes in the same direction, or that is parallel to this bottom plane. Can I do midpoint again? Yeah, I can. Okay, midpoint. Construct midplane, and then select two planes. It doesn't really matter which ones you select, as long as they're kind of somewhat spaced apart. So I'm just going to select the top and bottom one, but you're totally welcome to select like the top and the middle one or something like that. Okay, so I have all these extra planes. So now the question is, how are we going to use them? So if you look in the slides, we have this photo. You can see there's four circles. And from the looks of it, it may look like they're all on one plane, but they're actually all on different planes. So they're each on their own plane. One of them is one of the original planes from the origin, and then the other three are on the planes that we just made. So to make this work, I'm just going to make sure that I utilize the origin for all of these drawings, just so all the circles line up the way we want it to. So now that I've created those planes, I'm going to make some sketches. So I'm going to create a sketch. I'm going to choose one of them. So in this case, I'm just going to choose this bottom one to start. I'm going to draw a circle at the origin, and I'm going to add some dimension to it. Oops, wrong one. Let's just start with 30. Yeah. So the circle is fully defined because I started from the origin and I added a diameter. So I'm going to finish this one. And then I'm just going to start walking up the planes and creating more circles. So I'm going to make another sketch, select the next plane, and then I'm going to make another circle. So again, starting at the origin, This time I'm gonna make it a little bit larger. Maybe do like 45 or something. I'm gonna make another sketch on the next plane up. Another circle at the origin. I'll make this one a little bit smaller, maybe like 40. And then the last one on the last plane. Let's make this one, I don't know, 35. Um, I'm assuming you said good shaped hair dryer. No, it doesn't have to be like a perfect hair dryer. I've seen some that look like super compressed or like super wide. That's totally fine, as long as you're getting the concept down. I might end up changing some of these later to make it look better, but again, it's fully up to you. Is everyone up to this point? Everyone good? Okay, I'm gonna assume you are. So now that we've made all of these, um, we're going to create a loft. So a loft will basically take some 2D profiles and then make a smooth transition between one of them to another. So you'll see once I start selecting them, it'll create like this smooth vase-like curve to create kind of the head of our hair dryer. Another thing to note is if you ever want to see one of the planes that you made, you can show them under construction. So usually it automatically hides the plane once you create a sketch on it. So if you ever wanted to reference it or look at it again, you can use the little eyeball here to show and hide them. I'm going to do the same with the origin since we're kind of done with that. I'm just going to hide it now. So it looks a little bit cleaner. And now we're going to create our loft. So to do that, I'm going to go under create and loft. And again, you can kind of see what it does. In this example here, it takes this, it takes the square or rectangle in the bottom, and then it smoothly transitions to the circle above it. In our case, they're all circles. So it'll be pretty smooth. So when I select the profiles, I want to make sure I select them in order because I'm pretty sure if you select them out of order, it'll kind of like loft backwards onto itself. So you see if I like select it in in the incorrect order, it'll loft to this middle plane and then it'll go down and then it'll go back up. So we don't want that. Oops. So we're going to select them in order and hit the sketches. Nice. Okay, let's try that again. So I'm going to create a loft and then I'm going to select them in order. And when I do that, you'll see it creates a nice smooth transition. So I'm going to press OK. I'm going to hide these sketches. But yeah, there we go. We have this hair dryer body. To me, I might want to change the dimensions a little bit, so I can go in and change it. So again, utilizing the timeline, I can find um, one of the sketches or features that I had earlier, edit it. Um, Maybe let's make this one slightly wider, starting to look a little bit better. You can also edit the planes that we were working with earlier. So let's say I wanted the hairdryer body to be longer, then I can go back in the timeline and change it. Maybe if I changed it to 70, It'll kind of elongate it a little bit. But yeah, it's good to go back and change things uh, if you're not satisfied with your design instead of like deleting it and redoing it. Anyways, we have our body here, but it's pretty solid, right? It's all a solid body and kind of want to hollow out the center. So to do that, we're going to use the shell tool. And then after that, we're just going to fill at the end, just so it's nice and not sharp. So what the shell tool does is you'll select a face, and then it'll hollow out everything inside of that, while leaving a thin outer shell, right? That's why it's called the shell tool. So it's right here next to the fillet tool. I'm going to select this face right here, and then it'll ask me what the inside thickness should be, right? So this is just kind of asking how thin do you want this outer wall to be? So in my case, I don't know, let's do like 5 and see what happens. So when I type 5, you can see, in my opinion, it looks a little bit thick. So maybe I'll reduce it to like 3 or something. Um, Seems fine to me. Press OK. And when I confirm it, you can see that it's a nice, even shell throughout the whole thing. So pretty satisfied with that. I'm going to add a fillet by clicking on the tool to the left of the shell tool. And I'm going to fillet this edge here. Um, right now, I really recommend you just fillet the outside edge, because I'm just going to show you something a little bit later. Um, and if you fillet both edges, then it will break that. But if you do end up filleting both edges, you can go back and change that later. So again, I'm just going to fillet the outside of this. Maybe do like not 22, maybe like 1.5 or 1.6. That's fine. Okay. So it's nice and smooth here. I confirm that. You go through the shell part again. Yes. Okay. So again, here's my solid body. I'm gonna click the shell tool up here, the top. I'm just gonna click this top face, and then I'm gonna specify the thickness of the wall. So I think I used 3, and then I'm just gonna press OK. The cool thing about the shell tool is if you select multiple faces, it will let me. It will continue to shell all the way through, right? So, I guess this is more realistic for a hair dryer because you want air to go in one way and air to go out the other. So maybe I'll just keep this. But oh, that's lagging. Okay. So if you select multiple faces, you'll see that the shell will pass through the whole body. So that's nice. Because I have 2 shells in the same spot, it's gonna get mad at me, so I'm just gonna delete that one. But yeah, we have our nice hair dryer head here with a nice hole that passes through the whole thing. So yeah, the next step is to create our handle here. Um, oops. To create our handle, So what I'm going to do is I'm going to create another offset plane. But I'm actually going to extend this plane to go beyond this hair dryer, and I'll show you um, how we're going to merge them in just a little bit. Oh, show the second shell again. Sure. For the second shell, again, the first shell is totally fine. But instead of selecting one face, I selected two faces. So when I add the shell, it will shell through and hollow out the whole thing. Again, that's you don't have to. I'm just showing you that um, the shell tool is capable of doing that. Yeah. Okay. So for the next step, we're going to start making this handle for the hair dryer. So I'm going to add another plane. In this case, it's going to be another offset plane. I'm going to choose one of these two planes here to offset from. So I'll just choose this one here. And then for the offset distance, I'm just going to make sure that it extends beyond the hair dryer. So I don't know, probably 30 should probably be enough. Yeah. So we have this plane sticking out outside this hair dryer. I'm going to create a sketch on here, and I'm going to start making the handle. So one of the things I like to do is sometimes when I have like a certain feature of my sketch, like to be, straight vertical or horizontal from the origin, and it's not on the origin. This is totally a preference thing, but sometimes I like to draw it kind of out of place from where it is going to be and then add the constraints in, right? So the reason why I do it is like it gives me a little bit more control and allows me to confirm certain things. Because sometimes you might draw something that looks vertical and it very well could be, but it may not always add the constraint automatically. So what I like to do is I just kind of draw something at an offset and then I'll add a constraint to lock it all in. So I'm going to create this circle. You see, ultimately, I want it to be centered on this green line here. So now that I have the circle here, I'm going to hold shift. I'm going to click the center of the circle and the origin, and then I'm going to make it vertical. And again, this kind of goes back to like the arbitrary placement. If I place like the circle a little bit more closer to the red horizontal line, when I, add this constraint, it will probably snap to the horizontal. So yeah, keep that in mind. Anyways, now that it's on this axis, I'm going to add a couple more constraints and then we're going to extrude it. So I'm going to specify the dimension from there to there, maybe like 20. Okay. Can you repeat how you lock it into the axis again? Sure. So I'm just going to make the circle, or I'm going to just make another circle on the bottom, but the process is the same. So I'm going to create a circle if my computer stops lagging. Okay, yeah. So I'm going to make a circle. Again, I'm going to be placing it arbitrarily close to the axis that I want it to be, but not quite on it, right? So sometimes, again, like you may have noticed uh, in like assignment one, if you drew the rectangle on like the red line or the green line or the blue line, um, though visually is on that line, it won't be constrained. So again, drawing the circle arbitrarily close. It's closer to this green line than the red line. So when I add the constraint, which is the horizontal and vertical constraint right here, I'm going to click the constraint tool first this time, just to show you can do it differently. I'm going to click on the origin and then click on the center of the circle. And when I do that, it constrains it. Okay. So the last thing I'm going to add is going to specify this diameter here. We set it to 25. And with that, you can see it's fully constrained, right? Um, again, if I drew a circle here, um, yeah, this is a great example here. So you can see here, if I draw like this circle uh, on the green line here, it is visually and like physically currently on this vertical axis. But because there's no constraint applied, um, it can move side to side. So if I start adding constraints, like, if I add this center distance there, and then like this diameter here, you'll notice again, I applied these two constraints, which is the same, different numbers, but it's the same as these two. You can see this one's blue and this one's black. And it's because though it looks like it's on this axis, which it is, it's not constrained. So I'd have to constrain it by selecting those two and making it vertical. There you go. So it's just a little tip. Anyways, I'm happy with this circle. It's fully constrained. I'm going to finish it and I'm going to extrude it. Again, you can see how it's kind of floating away from this head of the hair dryer, but we're going to fix that in just a moment. So the way we're going to do it is we're going to create a two-sided extrusion. Um, so instead of the direction being one side, I'm going to set it to two sides. And you can see there's two arrows now, right? It's giving us two options on which way to extrude it. Side one, I believe, is this blue arrow because that's the first one it starts with. So I want it to go down that way to make the handle. So I'm going to add a dimension, maybe like 50, maybe even more. Okay, that looks okay. So I have this one, but you can see it's not, touching the head of the hair dryer. So to fix that, because it's a two-sided extrusion, I can extrude it the other way too. So let's do, I don't know, maybe something like 20. Um, you'll see here that Fusion is like assuming that I want to cut this uh circle shape out of uh the hairdryer head. In this case, it assumed incorrectly because I want it to be another body or a combined body. So instead of the operation as cut, I'm going to set it to join. And when I change it, you can see it turns gray again. And it looks like they're nice and combined, right? So that's what we like. I'm satisfied with this. I'm just going to change this to 25. Uh, and then I'm going to confirm it. So now you can see we have this hair dryer head and handle. So it's all one body. The outside looks good, but if we look at the inside, My computer stops lagging. Thank you. You can see that the when we extruded the handle into the head, we extruded too far, right? We went through the shell and into center of, where the air would theoretically flow through. And, that probably isn't great for airflow. So we would want to kind of remove that. So one thing we could have done is we could have just like extruded it to be exactly, up to the surface if we wanted to. But I'm going to show you a way to fix that using the timeline. Again, this is a useful tip depending on your scenario. If you've been following along exactly, then this should work pretty well. Again, make sure with this fillet, it's just the outside, because if you uh, have it on both sides, it's not going to let you do this. So the cool thing about a CAD program like Fusion is that you can actually change the order at which you do the operations in your timeline, right? So, you know, down here, it goes in order. So, we created our planes here at the beginning. We created a bunch of sketches. We added that loft and the shell all the way to where we are here. But we can change the order. Um, So in our case, we can move this shell and push it up to be beyond this extrude, and you can just watch, see what happens. So I'm going to go in the timeline. I'm going to hold down this shell feature that we made, and I'm going to drag it forward. So you can see like a little black line. I'm dragging it to the front. And when I do that, the whole extra extrusion disappears. And if we rotate a little bit, you can actually see that because we changed the order at which we did these operations, it actually shelled out the handle too. So depending on the scenario, that might be something you want to do. In this case, I did want to do that, so that's why I'm happy. If you were to accidentally fillet both sides of the shell, it's not going to let you push the shell forward. And the reason is yeah, that's totally fine. Um, the reason is, uh, if you can't push the shell forward, it might be limited by the fillet, because if you try to move the shell in front of the fillet, it's basically like moving what they might call like a parent feature, like before like the child feature, right? So like here, I'll just do it real quick. So if I was to create an extra fillet here, like at like half a millimeter, this fillet um feature is dependent on this shell feature, right? I wouldn't have been able to make this fillet without the shell being there. So if I try to drag the shell forwards, it's not going to let me. So that's just something to keep in mind when you're making stuff. So again, if I delete that fillet feature, it lets me. Come on. If I remove that and I try to push the shell forward, it will let me do it again. How do you hold and drag the shell? It's just a simple left click. So just like, holding down uh, on, most things. Again, if it's not dragging, it's probably because of, a dependent feature like a fillet or something. Does that make sense to everyone? Again, I purposely did all of this out of order just to show you extra features. So, you totally could have just done it in this order to begin with. Um, but I'm trying to show you that there's uh, a lot of things that you can do after the fact if you so desire. Okay. So the next step is to create a chamfer on this handle. So to do that, I'm going to go under modify and chamfer. Again, it's very similar to a fillet, but instead of a radius, it's just a straight cut. I'm going to specify some size, like, I don't know what let's see. I'm kind of curious. Okay, yeah. So I'll just do this just as another example. So you can see if I want like this chamfer to be really big, it actually starts to cut into the shell that we made earlier. So let's say we really want the hair dryer to be shaped this way. You can see that the order in which we model things can affect the design. So I'm going to confirm it for now. But you can see that we have like a floating piece here and like this completely missing section. And it's because we're adding a chamfer to something that was already shelled out. But again, if we change the order, I'm going to move the chamfer to happen before the shell. You can see now that just by moving it, it's now solid, right? And it's because when you chamfer something and you cut away from it, it's cutting away at something that is already hollow on the inside. So if you change the order and chamfer it before, it will hollow out everything underneath the chamfer instead of the chamfer cutting away at something that already wasn't there. So another example, why the order in which you model things or how the order in which you model things can affect your design. Does that make sense? I'm going to assume it does make sense. There's no one saying anything. All right. So now that we have the chamfer, the last part of this design is to create this little wire here. So we're going to be using the sweep tool to do this. So how the sweep does, or how the sweep works, is it wants two sketches, right? It's going to ask you to create a profile and a path. So the path in this photo is like this, curved line with like the arc and stuff. Um, and then the profile is kind of the shape at which you're going to extrude along the path, right? So because we're making a wire, we want the profile to kind of be like a circular shape. So you can see here, we're going to create a circle and then it's going to follow the path that we create. So going back to Fusion, we're going to create those two sketches. I'm going to start with the easy one by just making a circle on this plane right here. So I'm going to create a sketch. I'm going to click on this face, and then I'm going to make a circle that's centered on here. So I should be able to do it by drawing an arbitrary circle. Again, this is very similar to like the vertical line thing. I can draw an arbitrary circle, hold shift. In this case, I'm going to select this edge right here, and then I'm going to make them concentric to each other. So when I do that, you can see it snaps itself to be centered. You can also confirm it with like this little icon of the sketch along with the center point of the circle to be black because it's fully constrained. So now all I have to do is specify the diameter. So I'm just going to do like 4 or something, fully constrained, finish the sketch. And then now I'm going to draw the path that I want the wire to run along. So I'm going to create a sketch and I'm going to select this plane right here. If you look at the plane, because we drew everything kind of centered on the origin, this plane here cuts straight down the middle of this cylinder. So in our case, thinking a little bit ahead can save you some hassle so you don't need to make extra planes later. So I'm going to select this plane here. What is that whole feature in the timeline? Are you talking about this right here? This is the shell feature that like hollowed out the hair dryer. I'm assuming that's what you're talking about. Anyways, uh, I opened the sketch on that plane, so I'm just gonna snap myself to the front here. And now I'm gonna start drawing this profile. So I already drew, because I already drew the sketch first, you can see I can kind of build off of it. Another thing that you could do is project something that already exists. So if I wanted to, I could project uh, this circle onto the sketch. So what that does is it'll create a purple line that I can reference. So in this case, it's not really needed because I already have this sketch here, but I don't know, let's just say for whatever reason that sketch wasn't there. Um, I want to draw off the center, but I can use this existing geometry to build off of it. So I'm going to press P for project, and then I'm going to select this edge right here. You can see it'll kind of preview with this vertical line, and then I'm just going to press OK. There's probably better use cases for this, but I want to make sure you have this tool. Um, the project uh, feature is pretty useful when you have um, features that already exist that you want to reference. Instead of drawing it again and again, you can just say like, oh, hey, like I want to pull this dimension or this arc onto the plane. In this case, since the circle is like perpendicular to the plane that we're drawing it to, it'll create a vertical line um, instead of a circle. So to create that wire, I'm gonna draw off the center of the projected line that we just drew. You can see it's the midpoint because there's that triangle icon next to my mouse when I snap it to the center. So that's where I want to be. Uh, I'm just gonna draw out at an angle that I'm gonna fix later. And then to finish it off, I'm just gonna be using this fit point spline. So I'm gonna select it and then I'm just gonna start clicking away. And you can see it'll create like a smooth curve uh, following through the points. When I'm finished, I'm just gonna click this check mark here. You can see when I created that spline, um, there's kind of a uneven transition here. Yeah, I can do project in just a little bit. I'm gonna finish this real quick. So there's an uneven transition here. So to smoothen it out, I'm gonna use the tangent tool. So I'm going to select the spline and the line. You can see creates a nice smooth transition. And then I want this line to be going straight out. So I'm going to use the horizontal constraint, just like this. Um, this wire is kind of arbitrary, so don't worry about it being not fully constrained, but you kind of move it around and manipulate it to be whatever shape you like. Um, yeah, I'll just quickly go over the projected line before we do the sweep. So to project something, I'm just going to project this line or this circle right here onto the sketch. So I'm going to hit P for project. Um, and then I'm going to select what I want to project. In this case, it's going to be this end, the cylinder. And then when I press OK, I'll hide the body real quick. You can see that it gives me a line that represents the circle. So again, there's a bunch of use cases for this. I'm just showing you this tool, so this may not be the best use case, um, but I want you to know that this tool is there because it's pretty useful. All right, so with our path fully drawn, I'm going to finish the sketch here. I'm going to show the circle. Um, Once we created that, and then now we're going to make a sweep. So it's kind of similar to a loft, but instead of using multiple planes, it just uses one profile that follows a path that you create. So right next to loft, I'm going to select sweep. When I project the circle, I'm getting a purple circle instead of a line. Okay, that's likely because you're drawing a sketch on the wrong plane. Because if you draw a sketch on, this highlighted region, then when you project the circle, it'll be a circle. But because I'm drawing a sketch on the front plane, like from this view, the circle from this perspective is actually a line. So I would check the plane that you're sketching on. If that makes sense. Anyways, to create our loft, I'm going to go under create. I mean, yeah, create our sweep, sorry. Create and sweep right above the loft tool. It's going to ask for the profile and the path. So again, the profile is the circle that we were using or that we sketched earlier. And then the path is that line and the spline that we made on the second one. So I selected the profile already. I'm going to click this to select the path. If I do, creates a nice wire for us. Then I'm going to press OK. And there we go. We have our hair dryer, chamfered end, filleted top, and a nice wire going out the bottom. All right. Before I go over the homework, is anyone confused on this assignment? Okay, I guess not. All right. So it's almost 7:30, so I'm going to go over the homework, and then I'll let everyone go. So for your homework for this week, it's to be replicating an extrusion profile. Um, oh, my extrusions are over there. Anyways, basically, um, this is an extrusion profile, right? So It's used in a lot of uh, different places to kind of easily put things together and make frames. So if you're familiar with 3D printers, I have a Voron. Uh, it's just kind of like a it's just kind of like a name of like a group and project who designed something. Um, I can actually show you. Um, Yeah, if you look at my camera, that's my boron right there. But the frame is made of these extrusions that you see on the slides. So um, these extrusions are pretty cool just because it has these features that allow you to easily attach them to each other. You can use like these connectors, like like T's or like L's to kind of make whatever shape you want. But your goal for your homework assignment is to recreate this drawing. So this is the assignment that the dimensions actually matter. So please utilize these dimensions. Um, there are a couple missing dimensions from this image, so please reference this photo. This photo is also a pretty good hint to how I would go about drawing this up. So again, this isn't a fully finished sketch because, it's not the full extrusion profile. But if you can get to this point, you're basically done, right? So you can see here, if you just mirror all of these lines and arcs along this diagonal line here, you'll get like one corner of it. And then if you circular pattern the whole thing, you'll get your whole profile. So yeah, for this assignment, make sure your sketch is open when you submit it and you take your screenshot because I want to make sure that you're utilizing all of these dimensions only once, right? So if you use geometric constraints properly, you shouldn't have to add any extra dimensions um, to make all these lines fully constrained. So again, your goal is to have all the lines to be black, um, and you should be able to do it with all of these dimensions only being used once. Again, something useful that you might want to use is like the equal uh, constraint, right? So like all of these little radiuses are all the same size. So you can dimension one of them and then all of them will be the same. Um, you can use parallel and perpendicular in many ways to make this work too. So making sure or just utilizing all the constraints available to you um, will allow you to create this. Again, for this assignment, please don't use the fixed constraint because that's not the goal. The goal is for you to use all the rest of the geometric constraints um, to create this profile. Again, when you take a screenshot, it'll be with your sketch open. So if you did fix something, right, I will know because the line will be like that greenish yellow. So yeah, don't use the fixed constraint. And you can use this slide as a hint uh, to how to do it. Another thing that I did here is I created like this square out of construction lines. So you can see all of these dash lines are construction lines, and I made it a square. So these two lines are equal to each other, and you can use that as a base for your whole drawing. Um, I guess another tip for you before you go is you can simplify the drawing to start and then add complexity later. So one thing that I sometimes do is I might draw something that's kind of simplified and then, you know, I might draw this profile without all of these radii. And then once that's fully constrained, I'll add in the radii, trim away the excess, and then fix any constraints that may have broken because of the trimming. So that's a tip that, you could or could not use. Um, everyone designs in their own way, so uh, you don't have to use that. Um, but yeah, if anyone has any questions on this homework assignment, feel free to ask in the Discord. We'll try to respond as quickly as we can. But I will say that this is probably one of the more challenging assignments. So if you need help, don't hesitate to ask. And again, if you ask in the Discord, you may be helping someone else out too. So yeah. But yeah, it's 7:29, so we're done a little bit early. So if anyone else, or if no one else has any questions, you're feel free to leave, and I'll see you next week. Make sure you do your attendance if you haven't done it already. Um, but yeah, see you later.